Do discharged AA batteries weigh less than fully charged batteries? From experience, and with no anecdotal evidence, one would think no. But I was asked this question about 20 years ago, and I was reminded of this recently when I was carrying out some precision weight measurements for a client where a product needed to meet a specific weight range to comply with an international standard. At the time of being asked the question about battery weight, I answered that the battery's weight wouldn't change. But the story behind the question was that a customer bought a battery-operated child's toy from a shop at the Doncaster shopping town in Melbourne, Australia. When they got home and put batteries in the toy, it didn't work, so the customer returned to the shop and the sales assistant checked the product and then removed the batteries and said, "There's your problem, the batteries are flat." The customer asked, "How can you tell?" And the sales assistant said, "I can tell by the weight, they're empty." Now, I expect that the shop didn't sell batteries, or a quick test with new batteries would have resolved the issue. But thinking about it now in more detail, we know from basic circuit theory that a battery regains the electrons that it loses. Completing the circuit allows a chemical reaction in the battery to occur, and due to the potential difference, electrons flow from the anode to the cathode or from the negative to the positive terminal. We know that lead-acid batteries condense small quantities of hydrogen gas, especially if overcharged, but sealed primary AA batteries or rechargeable nickel metal hydrides shouldn't lose any material. Although over time, through self-discharge, hydrogen may build up inside, which is the likely cause of batteries leaking the electrolyte through the seals or casing. So let's take 4 brand new AA alkaline batteries and weigh them accurately. I'm going to wear gloves so as not to contaminate the batteries with any dirt or oils from my fingers or anything that might add weight, although I'm sure this difference would be negligible. I'm also going to keep the test environment at approximately 20 degrees Celsius to ensure consistency. However, again, I don't expect temperature to be a factor. So, battery 1 is 23.607 grams. Battery 2 is 23.674 grams. Battery 3 is 23.596 grams. And battery 4 is 23.576 grams. So the weight is fairly consistent, with a 98 milligram difference from lightest to heaviest. Now let's measure the unloaded voltage of each battery. Battery 1, 1.606 volts. Battery 2, 1.606 volts. Battery 3, 1.606 volts. And battery 4, 1.606 volts as well. It surprises me that they are all exactly the same, as I would expect some slight variation. Now let's completely flatten 2 of the alkaline batteries. Experience has shown that you can short out a new AA battery without too much going wrong. The battery will get very hot, probably in excess of 50 degrees, so I probably wouldn't try it. The current is limited by the battery's internal resistance. For a AA battery, this is usually about 60 milliohm, so this limits the current flow. However, to replicate a real-world discharge, I'm going to run our 2 AA batteries through a 3.6 volt light globe, which has a resistance of 0.8 ohms. At several times, the battery was shorted to examine maximum current flow and to speed up the discharging process. The total discharge circuit load was 2.7 ohm, which was made up from 0.8 ohm from the globe, 1 ohm from the ammeter, and 0.9 ohm from the remainder of the wiring. So we have now discharged the 2 batteries, and we've shorted the battery right at the end to discharge it as much as possible. And the final current that we're drawing is 40.82 milliamps and a voltage of 56.57 millivolts. So we are going to consider this battery as being flat. So let's reweigh the batteries. Battery 1, after discharge, is 23.605 grams, and battery 2 is 23.671 grams. So battery 1 is 2 milligrams lighter, and battery 2 is 3 milligrams lighter. Let's also look at some nickel metal hydride rechargeable batteries that are labelled with a minimum capacity of 1900 milliamp hour. Battery 1 is 26.310 gram. Battery 2 is 26.186 gram. So we see that these are about 3 grams heavier than the primary non-rechargeable batteries. And as for the unloaded voltage, battery 1 is 1.353 volt and battery 2 is 1.351 volt. So let's completely flatten these again and reweigh them. After discharge, the voltage of the rechargeable battery number 1 is 0.127 volt and battery 2 was 0.798 volt. Now for their weight. Battery 1 was 26.309 grams and battery 2 was 26.185 grams. So we see a reduction in weight of 1 milligram for each battery, which is pretty negligible. Considering the repeatability of the testing and the accuracy of the analytical balance, I think we can conclude that there is no change in weight between a fully charged AA battery and a discharged one. At least not enough for a person in a shop to be able to tell by holding them in their hand. Although from experience, some original equipment manufacturers' batteries that are supplied with new products and what I imagine are pretty cheap and nasty do sometimes appear to be noticeably lighter than branded batteries. So let's look at some others. Here we have a fully charged Eveready Super Heavy Duty. The weights are battery 1, 15.803 grams and battery 2, 15.925 grams. This is more than 7 grams lighter than the Duracell batteries and 10 grams lighter than the rechargeables. And if we take some completely flat no-name 300 mAh nickel cadmium batteries, the weights are 12.329 grams and 12.559 grams. Therefore, we could have a total difference in weight between AA batteries of about 14 grams, which is significant. Just by holding these batteries, I can tell a noticeable difference in the feel of the weight between the NiCad and the Duracell, and even between the Eveready and the Duracell. So we would expect that this weight difference translates to capacity, but that's a test for another day. Therefore, going back to the shop assistant and the batteries in the kid's toy, if that person was used to handling high quality alkaline batteries and was now confronted with cheap low capacity batteries, you could understand that the noticeable weight difference may make them believe that the battery was empty. However, we can prove from these tests that the weight change from a fully charged to fully discharged battery is negligible and would unable to be detected by a human hand.